This video covers section 4.2 homework, graphs of functions. Let's get started. Question 1 says, create a table to identify the graph that represents the function f of x equals 4x minus 1. It may say that we need to create a table, and that is one method of solving this function. You could choose a few values for x, plug them in to the function, and then choose the graph that contains those points. However, the computer does not care how we find the answer as long as it is correct. Since this function is in the form of y equals mx plus b, we can find the slope and y-intercept to identify the correct graph. Remember that whatever number is in front of x is your slope, and the constant number by itself is your y-intercept. Looking at this function, I can see that my constant, the number by itself, is -1. So any graph that does not have a y-intercept of -1 can be eliminated. I can eliminate the first answer choice because it has a y-intercept of +1. Answer choice 2 does have a y-intercept of -1, so I'll leave that as a possible answer. Answer choice 3 can be eliminated because it also has a y-intercept of +1. Answer choice 4 can be eliminated because it has a y-intercept of 0. This means that answer choice 2 is my only option left. I can confirm that it is correct by looking at the slope. The number in front of x is +4. This means we have a positive slope. So our line should be going up and to the right, or down and to the left. If your slope is negative, it should go up and to the left, or down and to the right. This means I can eliminate answer choices 3 and 4 because they have negative slopes. Since answer choice 2 is the only one that passed both the y-intercept test and the slope test, it has to be the correct answer. Question 2 gives us a function and asks us to evaluate it for several values and create the graph. Now you can plug these values in for x and use them to graph the line, but I find it easier to graph the line first and then find the values from the graph. To do that, I'm going to find the slope and y-intercept for this function. Remember that slope is the number in front of x, and the y-intercept is the constant number by itself. The number in front of x is -2, so that's my slope. And the constant is 1, so that's my y-intercept. I can place my first dot at my y-intercept of 0, 1. Now I can use my slope to find my rise and run. Since my slope is a whole number, I'll put a 1 underneath it to convert it to a fraction. Remember that rise is the number on top and run is the number on bottom. I can see that my slope is negative, so this time I'll be moving up and to the left, or down and to the right. If your slope is positive, you'll go up and to the right, or down and to the left. My rise is 2, so I'll go up 2 squares. My run is 1 and my slope is negative, so I'll move left 1 square and place my second dot. Now I can evaluate the function for the given values. The first value I need to find is f of -2. This means it wants to know the y value for the function when x equals -2. If I find -2 on the x-axis, I can see the function crosses that grid line when y equals 5. This gives me my first answer of f of -2 equals 5. For f of -1, I can see the function meets the x equals -1 grid line when y equals 3. So my next answer is f of -1 equals 3. For f of 0, I can see the function meets the x equals 0 grid line, also known as the y-axis, when y equals 1. So my next answer is f of 0 equals 1. For f of 1, I can see the function meets the x equals 1 grid line when y equals negative 1. So my next answer is f of 1 equals negative 1. Question 3 simply wants me to graph the given function. Since it's a linear function in the format of y equals mx plus b, I can graph it by identifying the slope and y-intercept. Remember that the slope is the number in front of x, and the y-intercept is the constant number by itself. The number in front of x is 2, so that's my slope. And the constant is 5, so that's my y-intercept. I can place my first dot at my y-intercept of 0, 5. Now I can use my slope to find my rise and run. Since my slope is a whole number, I'll place a 1 under it to convert it to a fraction. Remember that rise is the number on top and run is the number on the bottom. I can see that my slope is positive, so this time I'll be moving up and to the right or down and to the left. If your slope is negative, you'll need to go up and to the left or down and to the right. My rise is 2, so I'll move up 2 squares. My run is 1 and my slope is positive, so I'll move right 1 square and place my second dot. Question 4 wants me to match each graph with the correct function. Since these functions are quadratic functions, I can't use slope-intercept to identify the correct graph. I'll need to use the transformation rules of quadratic functions to choose the correct graph. All these functions are in the form of ax squared. So that is the type of transformation I will focus on. If a is positive, the curve of a quadratic function, called a parabola, opens upward. If a is negative, the parabola opens downward. If the absolute value of a is greater than 1, the parabola gets steeper and narrower. If the absolute value of a is between 0 and 1, the parabola gets shallower and wider. I find it easier to look at the functions first, then choose the correct graph from there. My first function is f of x equals 4x squared. The number in front of x squared is 4, so that's my a value. 4 is positive, so the parabola must open upwards. That eliminates the first graph because it opens downwards. 4 is greater than 1, so the parabola must be steep and narrow. That means the third graph goes with f of x equals 4x squared. My next function is g of x equals negative 4x squared. The number in front of x squared is negative 4, so that's my a value. Negative 4 is negative, so the parabola must open downwards. That eliminates the second and third graphs because they open upwards. The absolute value of negative 4 is 4, and 4 is greater than 1, so the parabola must be steep and narrow. That means the first graph goes with g of x equals negative 4x squared. This means that the last function, h of x equals 1/4 x squared, must go with the second graph. I can confirm this by looking at the a value of 1/4. 1/4 is positive, so the parabola opens upward, and 1/4 is between 0 and 1, so the parabola must be wide and shallow, which matches up with the second graph. Question 5 says match the following functions with the correct blue line on the graphs below. The black line is the parent function g of x equals x squared for comparison. Although these functions are quadratic functions and not linear, I can still find the y-intercept by looking at the constant number by itself in each function. In quadratic functions, the constant is referred to as the c value. The first function, f of x equals x squared minus 4, has a y-intercept of negative 4, and the second function of f of x equals x squared has a y-intercept of positive 4. For graph A, the blue line has a y-intercept of positive 4, so it must go with the second function. For graph B, the blue line has a y-intercept of negative 4, so it must go with the first function, f of x equals x squared minus 4. Question 6 is similar to question 5. However, instead of having quadratic functions in the form of ax squared plus c, these are in the form of ax squared plus bx. This means that the easiest way to pick the correct graph is to find the vertex of each function. The vertex is the point at the bottom of the parabola, and if a function is in the form of ax squared plus bx plus c, we can use the formula negative b divided by 2a, where b is the number in front of x and a is the number in front of x squared. Negative b divided by 2a will give us the x-coordinate of the vertex. We can then plug that value into the function to find the matching y-coordinate. The first function is f of x equals x squared minus 2x. Remember that if there isn't a number in front of a variable, we assume that there's a 1. That means that for this function, my a value is 1, and my b value is negative 2. So I'll set up negative b divided by 2a as negative parentheses negative 2 divided by 2 parentheses 1. That will give me 2 over 2, which is 1. That means my x-coordinate for the vertex of the first function is 1. Looking at the graphs, you can see the first graph has a vertex when x equals positive 1, and the second graph has a vertex when x equals negative 1. That means this first function goes with the first graph, and by process of elimination, the second function, f of x equals x squared plus 2x, goes with the second graph. Question 7 says, would the graph f of x equals negative 6x squared plus 10x plus 14 open up or down, and why? Remember that when you have a quadratic function in the form of ax squared plus bx plus c, the a value determines the direction of the parabola. If a is positive, the parabola opens upwards. If a is negative, the parabola opens downwards. This means I can eliminate the second and third options because they are both based on the b value instead of on the a value. If I look at my function, I can see a is negative 6. This means the parabola will open downwards, making the first answer choice correct. Question 8 gives us a quadratic function and wants us to find the vertex and then graph the function. Remember that if a function is in the form of ax squared plus bx plus c, we can use the formula negative b divided by 2a, where b is the number in front of x and a is the number in front of x squared. Negative b over 2a will give us the x-coordinate of the vertex. We can then plug that x value into the function to find the matching y-coordinate. My a value will be 4, and my b value will be negative 16. So I'll set up negative b over 2a as negative parentheses negative 16 divided by 2 parentheses 4. That will give me 16 over 8, which will give me an x-coordinate of 2. Now I can plug in 2 for x and evaluate my function to find the y-coordinate of the vertex. I'll set this up as f of 2 equals 4 parentheses 2 squared minus 16 times 2 plus 15. In order of operations, exponents come first. 2 squared will give me 4, so I'll have f of 2 equals 4 times 4 minus 16 times 2 plus 15. Next, I'll do my multiplication and division from left to right. First, I'll multiply 4 and 4, giving me f of 2 equals 16 minus 16 times 2 plus 15. Next, I can multiply negative 16 and 2, giving me f of 2 equals 16 minus 32 plus 15. 16 minus 32 will give me f of 2 equals negative 16 plus 15, which will give me a final answer of f of 2 equals negative 1. This means that my vertex is at 2, negative 1. To graph my function, I'll need a second point to graph. I could look at the constant to find the y-intercept, but my constant on this function is 15, which is too high to show up on my graph. If you want to see how to graph using a y-intercept as your second point, look at question 9. Instead, I can find one by plugging in a second x value into my function. I'll use the x value of 1, but you can use almost any x coordinate, although I recommend using an x value that is 1 greater or smaller than your vertex. This is because numbers further from the vertex can often have y values that will place them above or below the graph, meaning we can't use them to graph the line. Plugging in 1 for x will give me f of 1 equals 4 times 1 squared minus 16 times 1 plus 15. 1 squared is 1, so now I have f of 1 equals 4 times 1 minus 16 times 1 plus 15. Multiplication from left to right will leave me with f of 1 equals 4 minus 16 plus 15. 4 minus 16 is negative 12, and negative 12 plus 15 is positive 3. So f of 1 equals 3. This will give me a second coordinate to graph at 1, 3. Now I can graph my parabola by placing a dot at the vertex of 2, negative 1, and a second dot at 1, 3. Question 9 is the same as question 8. We have a quadratic function and it wants us to find the vertex and then graph the function. Remember that if a function is in the form of ax squared plus bx plus c, we can use the formula negative b divided by 2a, where b is the number in front of x and a is the number in front of x squared. Negative b over 2a will give us the x-coordinate of the vertex. We can then plug that x value into the function to find the matching y-coordinate. My a value will be negative 2, and my b value will be 8. So I'll set up negative b over 2a as negative parentheses 8 over 2 times negative 2. That will give me negative 8 over negative 4, which will give me an x-coordinate of 2. Now I can plug 2 in for x and evaluate the function to find the y-coordinate of the vertex. I'll set this up as f of 2 equals negative 2 times 2 squared plus 8 times 2 minus 9. In order of operations, exponents come first. 2 squared will give me 4, so I'll have f of 2 equals negative 2 times 4 plus 8 times 2 minus 9. Next, I'll do my multiplication and division from left to right. First, I'll multiply negative 2 and 4, giving me f of 2 equals negative 8 plus 8 times 2 minus 9. Next, I can multiply 8 and 2, giving me f of 2 equals negative 8 plus 16 minus 9. Negative 8 and 16 will give me f of 2 equals 8 minus 9, which will give me a final answer of f of 2 equals negative 1. This means that my vertex is at 2, negative 1. To graph my function, I'll need a second point to graph. The easiest way to do that is to look at my constant to find my y-intercept. For this function, my y-intercept is at negative 9, which will fit on my graph. If your y-intercept does not fit on your graph, you'll need to plug in a second x value into the function to find a second point for the graph. To see an example of that, look at question 8. So I'll place my first dot at my vertex of 2, negative 1, and my second dot at my y-intercept of 0, negative 9. Question 10 wants us to graph f of x equals the negative square root of x. The easiest way to do that is to plug in x values to create a table and then match that with the correct graph. It is important to know that we cannot take the square root of a negative number. This means the part of the function inside of the square root cannot be smaller than 0. Since x is the only thing inside of the square root, the smallest x value I can use is 0. If I plug in 0, I'll have f of 0 equals the negative square root of 0. The square root of 0 is 0, so this will simplify to f of 0 equals 0, giving me my first point at 0, 0. Looking at the answer choices, I can eliminate the first and third graphs because they do not contain the point 0, 0. For my second x value, I'll use x equals 1. If I plug in 1, I'll have f of 1 equals the negative square root of 1. The square root of 1 is 1, so this will simplify to f of 1 equals negative 1, giving me a second point at 1, negative 1. This means I can eliminate the second graph, leaving me with the fourth graph as my correct answer. Question 11 wants us to match three functions in the form of f of x equals a times the square root of x. Similar to question 4, there are some rules I can follow to help me match the correct function with the correct graph. If a is negative, the graph will have a curve going down. If a is positive, the graph will have a curve going up. If the absolute value of a is greater than 1, the curve will be steep and go up or down quickly. If the absolute value of a is between 0 and 1, the curve will be shallow and go up or down slowly. My first function is f of x equals the negative square root of x. Since there is not a number in front of the square root symbol, I can assume there is a 1 there. This makes my a value negative 1. Since it is negative, the graph will have a curve going down, meaning the first function goes with the second graph. My next function of f of x equals 3 times the square root of x. Since my a value is positive 3, the curve will be going up and steep. This means that the second function goes with the third graph. On my last function, my a value is 1/3. Since this is between 0 and 1, the curve will be shallow. This means that the third function goes with the first graph. Question 12 has functions in the form of f of x equals the square root of x plus c. Because here the constant is outside of the square root symbol, that means it will move the graph up or down from the parent function of f of x equals the square root of x. The parent function starts at 0, 0. This starting point is referred to as the vertex because it is the start of the curve. Since there isn't a number inside of the square root symbol, the constant is the same as the y-intercept. If, however, there's a number inside the square root symbol, it gets more complicated than that, but we'll deal with that on question 13. The first function is f of x equals the square root of x plus 1. C is 1, which means the vertex is 1 square above 0, 0 at 0, 1, matching it with graph B. The second function is f of x equals the square root of x minus 3. C is negative 3, which means the vertex is 3 squares below 0, 0 at 0, negative 3, matching it with graph C. The third function is f of x equals the square root of x minus 1. C is negative 1, which means that the vertex is 1 square below 0, 0 at 0, 1, matching it with graph D. The fourth function is f of x equals the square root of x plus 3. C is 3, which means the vertex is 3 squares above 0, 0 at 0, 3, matching it with graph A. Question 13 is similar to question 12. However, this time we have functions in the form of f of x equals the square root of x plus b, with a constant inside the square root symbol. This means that instead of shifting the graph up or down, it will shift the graph left or right from the parent function, which starts at 0, 0. The starting point is called the vertex. If b is positive, the graph will shift left. If b is negative, the graph will shift right. Just remember that when the constant is inside with x, it does the opposite of what you would expect it to. The first equation is f of x equals the square root of x plus 2. B is 2, which means the vertex is 2 squares left of 0, 0 at negative 2, 0, matching it with graph B. The second equation is f of x equals the square root of x minus 3. B is negative 3, which means that the vertex is 3 squares to the right of 0, 0 at 3, 0, matching it with graph C. The third equation is f of x equals the square root of x minus 2, which means the vertex is 2 squares to the right of 0, 0 at 2, 0, matching it with graph D. The fourth equation is f of x equals the square root of x plus 3. B is positive 3, which means the vertex is 3 squares to the left of 0, 0 at negative 3, 0, matching it with graph A. Question 14 wants me to graph f of x equals 5 plus the square root of x minus 2. This will use techniques from both questions 12 and 13 to find the starting point for the graph. Remember, the parent function f of x equals square root of x starts at 0, 0. This starting point is called the vertex. The constant outside of the square root is my c value, which moves the vertex up if it is positive and down if it is negative. The constant inside the square root symbol is my b value, which moves the vertex left if it is positive and right if it is negative. For this equation, my c value is 5 and my b value is negative 2. This means my vertex is located at positive 2, positive 5. To find my next point, I'll plug in the x value that is 1 square to the right of my vertex. For my equation, that gives me an x coordinate of 3. If I plug that in, I get f of 3 equals 5 plus the square root of 3 minus 2. 3 minus 2 gives me 1, making my next step f of 3 equals 5 plus the square root of 1. The square root of 1 is 1, making the next step f of 3 equals 5 plus 1, which gives me f of 3 equals 6. So my second point will be at 3, 6. To graph this, I'll place my first dot at my vertex at 2, 5, and my second dot at 3, 6. This concludes section 4.2 homework, Graphs of Functions. If you have any questions, leave a comment or message me through Lumen or Remind. Remember to be safe, be smart, and try to make wise choices.